Okay, so I'm not sure how I feel about being up here on the stage. And it's like when I taught an old physics lab. Up high on the students down low. I'm going to start with my last slide. So this is going to be my last slide. So if you're interested in finding a copy of this presentation, it'll be at that website. If you're interested in contacting me, that's my email. And if you're into Twitter, and you're interested in the kind of stuff that you heard here, there's a fair bit of traffic about this through there and through some other hashtags. Okay? The paperclip is not as good as I thought it would be. Okay. The work I'm going to present is based on an awful lot of literature. And if you're interested in reading that, you just go to my website and find it. Some of these are not so boring. But I'm not going to tell you which one. All right, so this story starts about 13, 14 years ago. I was asked to come in and help a middle school teacher implement problem solving. So she knew me in the community. She knew I was interested in problem solving. I was a former high school teacher, and I was a PhD student at the time. So she reached out to me and asked me if I could help her with problem solving. So this was great for me because I love problem solving. So I came sliding into the school the next day for our meeting. And the first thing she said was, okay, hold it right there. I don't want any of your glee and enthusiasm in here. I don't want you to co-teach with me. I don't want you to co-plan with me. I just want you to give me some tasks. Maybe my email wasn't clear. That's fine. But if I give you a task, I get to watch what happens when you use it. She said, fine. So I took up a perch in the back of her grade 8 room, and this was the first task that I'd given her. 6 cats to kill 6 rats in 6 minutes. How many cats are required to kill 100 rats in 15 minutes? Okay? Awesome task. This thing it's got everything a grade 8 student needs. It's got fuzzy, little, warm, nice creatures. It's got death and blood and gore. This is going to be awesome. And I've used this task, actually, in many, many, many settings, and it's always gone well. It comes from Lewis Carroll. For those of you who don't know, Lewis Carroll was a mathematician. He actually wrote a lot of books about problem solving. Anyway, so Jane had never done problem solving in her class. I gave her this problem as a starter. What do you think happened?
Like what's happening now.
Oh boy. It was a disaster. Unmitigated disaster. Like this forest of arms went up. It eclipsed the sun. She ran from student to student to student for 40 minutes, pushing and pushing and pushing, trying to get them to do it. And while she was there pushing, they were making some progress, but as soon as she left, they just kind of sat there with their hand up. It was horrible. So she comes, after 40 minutes, she gets back to the regular lesson, gets them going on some activity, and she comes to see me back in the back of the room, and I'm thinking, okay, that's it, one and done, I'm out of here. She comes up and says, give me another task. Well, this woman's got tenacity. So I gave her another task, and the next day I was in there, back in the room. Disaster again. 40 minutes, she's running off her feet. Comes to the back of the room. Give me another one. Gave her another one. Next day, 40 minutes, disaster. She comes to me at the end, and she goes, I think that's enough. I said, yeah, I agree. Like, this was painful for everyone. The students were in pain. She was exhausted. I was bleeding inside from how bad it was. It was not good. So I left. So I said, can I just stay in your class for the rest of the day and watch what you normally do? So I did. I stayed there. In fact, I stayed there for 3 days. All day for 3 days. And on the third day, I had an epiphany. I realized that in the 3 days I've been watching her teach her regular content, at no point had the students been expected to think. They were doing stuff. They were filling in tables, they were solving questions. But everything that they'd been asked to do had absolutely no thinking left in it. All the thinking had been sucked out, either through her direct instructions, or her modeling or demonstrating how to do it. So I left her room and I went to another math classroom and I saw the same thing. And then another one I saw the same thing. And another one I saw the same thing. And for several months I actually visited a lot of classrooms all over the Lower Mainland of Vancouver. And I tended to see the same thing. And I thought, you know, it doesn't really matter how good our textbooks are. And it doesn't matter how smart our smartboard is. And it doesn't really matter how good our desks is, whether we got the desk where the seat is attached or they're detached, or we got the tables that are round, or nothing is going to matter until we get past this idea. Nothing is going to matter until we actually start to get students thinking. The person doing the thinking is the person doing the learning. And if your students aren't thinking, the best you can hope for that day is good behavior. So I started on a quest, and I spent a lot of time in what had been reported as good classrooms and bad classrooms. I just spent lots and lots of times in classrooms. And one of the things that I started to notice when I did that is that classrooms all over the world are more alike than they are different. It doesn't matter if I'm in a grade 2 class or a grade 12 class. It doesn't matter if I'm in a low socioeconomic setting or a privileged private school. It doesn't matter if I'm in Canada or Sweden or Korea or Taiwan or Chile. Classrooms, for the most part, look the same. They have students sitting in desks, usually oriented towards a teacher who stands up at what's the front of the room, and from which she or he provides knowledge to the students. There are a whole bunch of these elements that I started to realize were the same in every classroom. And I realized that they've been the same in every classroom for 100 years. Yeah, the desks have wheels on them now, and you know, the blackboard is now a whiteboard or a smartboard. But fundamentally, nothing has changed in the last 100 years. So I thought, you know, we've been struggling so long with education, maybe we need to pay a little bit of attention to some of the things that are taken as non-negotiable in classroom settings. So I started on a project. And I have no idea what my next slide is. Oh, it's that one. I started on a project that has pretty much kept me occupied for 10 years. And in this project, I've recruited more than 400 teachers to work with me. And the way this worked was, we started using something I call a contrarian approach. If we're going to tackle some of the things that have been seen as non-negotiable for so long, the best way to start is to just do the opposite. And let's see what the effect is. Students are used to sitting, let's make them stand up. They're used to us answering questions, let's stop answering questions. They're used to having furniture in the room, let's take the furniture out of the room. We got phone calls on that. They're used to teachers talking, let's try not doing any talking. That doesn't work. But this was the nature of our exploration. We systematically chipped away at every non-negotiable element of the classroom. And we always started with a contrarian approach. And sometimes a contrarian approach actually was the best option. But almost every time a contrarian approach brought us closer to what in the end was the best way than having to try to start at what was the non-negotiable. So what are the things we played with? We experimented with problems. There was this myth that if we really want students to learn through problem solving, all they have to do is find that magical book that they all know I have, which contains magical problems that all you have to do is open them up and it'll just wash knowledge all over the student. I don't have that book. But I had a feeling that maybe we need to, the kinds of problems we're using might actually make a difference. It's been a year and a half on it. How we give the problems. Every single teacher in a classroom will give a problem in typically one of a few ways. They'll write it on a board, they'll have them flip open to a page in the textbook, or they'll give them a handout. For the most part, or they'll project it on a board. Those were sort of the standards. Well, we experimented with all of those, and we experimented with other things as well. What are other ways we can give students problems? We experiment with how we answer questions. You know, students ask questions all the time. Teachers, we answer them all the time. We have a huge problem with something called learned helplessness. That we are all implicit in. Right? Learned helplessness comes from the fact that students have learned that being helpless is actually a really good way to move forward. So we experimented with how we answered questions. We experimented with how the room was organized. We tried having desks in rows, desks in pairs, desks in clusters. We tried bringing in tables, round ones, rectangular ones, square ones, those ones that are shaped like trapezoids. We put them in circles, in horseshoes. We tried the IKEA model. We got to walk around the room to get outside. We tried everything about the way the room was organized. We experimented with how groups are formed. Teachers do something called strategic grouping. It's February 17th. That means in 12 days, elementary teachers all over Canada are going to create new groups. And they use something called strategic grouping. Okay? You two should not be sitting next to each other. They cannot be together. I have this guy over here. He's nuts. He needs to sit with her because she's like a walking volume. She just takes all that energy up. And they do this strategic grouping. And sometimes the strategic is about ability. Sometimes it's about management. And we experimented with this. Does it matter? We experimented with student workspace. Desks, computers, tablets. We experimented with everything. We experimented with the type of autonomy that students have. Some students have no autonomy. Some students have more autonomy, and playing with that. We played with how we give notes. How do we get notes from us to students? Should I write them on the board and they write it down? Should I just upload them? Should I do fill in the blank? Hints and extensions. What is the best way to do hints and extensions? Okay. Or should we just do it like we normally do? Everyone try this one. 3 minutes and 42 seconds later, everyone come together. That's how you do that one. Now do this one. How we level. Leveling is what we do at the end of a task that we've asked the students to do. We play with assessment. We're still playing with assessment. I think we're going to be playing with assessment our whole life. Anyway, we learned something. And the way we learned it was, the teacher in Edmonton who goes and teaches for 3 weeks with no furniture in the room, we learned from that. Don't do that. Okay? And sometimes we learn things that are, oh, that didn't work. But maybe it didn't work because we needed to tweak it. Try tweaking it. Maybe we need someone else to try it. And we zeroed in on things that started to have powerful effect. And by powerful effect, the single measure we were looking for was, does this contribute to students' thinking? If we do these things, will they think more? Will they think better? All right? And we learn some things. So, we learned that you want to use good problems. I know that seems obvious. It took me a year and a half. But it turns out that good problems are different at different stages. And I'm not going to go into these details, but there's a category of problems that you need to use for about the first week. And then after that, it turns out good problems come right out of the textbook. There's nothing magical or mythical about it. They come right out of the textbook. But when you use those problems, there still has to be something left to think about it. So ixnay on the free teaching. How we give problems. This one was weird. So we're used to giving students problems in written form. The contrarian approach to that is oral. We give them verbally. It turned out that that worked. And it worked better than anything we found to tweak that. Every setting, every grade, every socioeconomic setting, every demographic, didn't matter what it was. Giving the students the problems verbally worked better every time. Now, to be fair, I can't give you the problem 3x to the 1/2 plus square root of x minus 3 equals x plus 2/3 all over 7. Go and do that. There are some problems we can give verbally, but there are other problems where we have to show the actual text or the graph, but all the instructions have to be verbal. Huge effect. Because when they're textual, the first thing the students do is they decode, they read. And if you have them in a group, they read separately. And if you have them in a group and you give them verbally, the first thing they do is they talk to each other, even if they don't like each other. Guess which was the worst for providing problems? The absolute worst source for getting students to do problems from. Yeah?
The textbook.
Yeah. The textbook. And it was like, verbal was really good, this was not bad, this was not bad, this was the textbook. The textbook has, sorry for the publishers here, the textbook has embedded in it an institutional norm that is shot through the learn helplessness. When students work from a textbook, they are expecting you to have shown them how to do it first. It's really relevant. Okay, how we answer questions. Well, it turns out that students only ask 3 types of questions. They ask what's called a proximity question. These are the questions we ask just because you happen to be standing close by. It's got a thing to do with establishing goals. You're close to me, the most studently thing I can do is ask a question. The most teacherly thing you can do is answer the question. Those are called proximity questions. They wouldn't put up their hand or walk over to you to ask them. They just ask if you're close by. There's something called stop thinking questions. These are the questions they ask so that they can stop thinking. The most obvious one is this right? Second most popular, is this on the test? They ask these questions because if you by some miracle manage to get them working, answering one of those questions will allow them to stop. And what we learned was we needed, and then there was a third type, which is called a keep thinking question. These are the questions they ask to clarify so that they can get back to work. What we learned was that if we answer either of the first 2 questions, we're actually feeding into this learner helplessness. But the third ones were really good. But we had this hilarious thing happen in the kindergarten class. Because when a teacher doesn't answer a question in kindergarten, what do a kindergarten student do? They follow them. Until they stop again, and then they ask the question again. kindergarten teacher weaving her way through the class. She had 7 kids lined up, like a little Congo worm. So we had to figure out things, what we could do instead of answering questions, and it turned out that the absolute best thing to do, we tried all sorts of things. What do you think? All these things. It turned out that the absolute best one, especially when you're starting out, is to just smile at them and then walk away. The smiling indicates that I've heard you. It's the acknowledgement. The walking away says I'm deliberately not answering. It turned out that the best rooms that we found thinking happening in were rooms that were chaotic. Rooms that were a little bit disarrayed. And one of the things we started to realize, and this comes from other research I was doing, is when a room has no discernible front, the students behave better. They are more apt to get engaged. They don't really know where to point their thinking at. But it radically transforms a space. If you can defront your room, the students will stop anchoring themselves to their desks as their place to think. 2 foot by 2 foot by 2 foot cube on top of your desk is just big enough for your notebook, your textbook, and your head. Right? But all of a sudden when it gets defronted, the room opens up and the whole space becomes something you can use. The absolute best way to form groups was visibly random. We tried every strategic approach we found. Randomizing the students frequently works better than anything else. I'll talk more about that in a minute. The actual best student workspace was to have them standing up and working on whiteboards for some reasonable proximity. They are, and I'll talk more about that in a minute. Autonomy, this is a new one actually. This work is ongoing. We found that in order for students to think, we have to create autonomy, which means we have to be ambiguous. We have to be elusive. And we have to give them the freedom to make choices about what they were going to do with this ambiguity. But it turned out that wasn't enough. Creating ambiguity was not enough. We have to actually push the students to use that ambiguity. And I'll talk more about that later. Best way to give notes? Don't. At least not the way we've normally done. It turned out that I did a whole bunch of research on students when they were sitting in their desks and the teacher was writing on the boards and the students were copying down what was there. That was how they were generating the notes. In every class I studied it in, more than half the class was at least one example behind the teacher, which means they weren't participating in the lesson part of it. And I never encountered a class where more than 5 students went back to their notes. Ever. Usually the number was 3. And then we studied also the fill-in-the-blank notes. They turned out to be worse. The students were paying attention, but they were only listening to the key pieces to fill it in. So we're still working on this, but we don't do notes in that. We make students write their own notes now. We call them notes to my future donor self. Anyway, Kitchen Extension is managing flow and how to level is leveling to the bottom. These are 2 very high-end strategies that I don't have time to talk about, and same with assessment. But I'm going to talk a little bit about a few of these things. Now, it turns out that these were all effective in transforming students to be thinking more and thinking better. What do these things have to do with thinking? And some of them seem strange. But it also turns out that they're not equally powerful, because if you go into school on Monday and the only thing you do is don't answer questions, you're going to have a bad day. Because that's a finishing tool. That's the sort of thing that comes later. What we found were that these tools organize themselves into categories. We played with this a lot. As to what are the quickest ways to transform a classroom into a space for students to think. These are the sledgehammers and chainsaws in the process. These are the framing hammers. This is the finishing tool. I've actually been playing with this a lot. I actually have a new way to represent this. First time ever you're going to see it. I think more about it like this. That we start on a journey. That we spend time using these 3 sets of tools. And when we're ready, we slide into the next set of tools. When we're ready for that, we slide into the next set of tools. Not answering questions is right there. You don't want to do that to start. So let's talk about some of the tools in the first wheel. Let's talk about random groups. Oh, sorry, visibly non-permanent surfaces. So, when we experimented with students and all the different things that they could work on, we found very quickly that students were most engaged when they were standing up and working on some sort of a whiteboard, or a window, or this is new technology. There was one in the class I was in. It's nice to see you guys have been upgraded. It's like a whiteboard, but don't use a whiteboard marker on it. Somehow, for some reason, when we got the students standing, we saw magic happen. Now, the cynic in me wanted to test this. So what I did was I constructed a controlled experiment. And the controlled experiment involved 5 different classrooms, right? 10, 11, and 12 classrooms. And in each classroom, I let the teacher decide what the groups would be. Lots of strategic grouping. But after she had decided what the groups would be, I decided what group was going to work on what surface. So some groups got to work on a whiteboard standing up. Other groups got a whiteboard at their desk that they worked on when it was on their desk. Other groups got to stand up and work on a sheet of flip chart paper that we had taped up on the wall, or butcher paper. Other groups got butcher paper on their desks. And the control group got to just work at their desks and their notebooks the way they normally do. Okay? Notebooks that don't plug in. I'm talking pen and paper stuff. Right? Now, this was 5 different classrooms, 5 different schools. Every group was randomly assigned to a surface. And then I measured some things about how the work went. I measured how long it took them to get going on the task. How long before they made their first mathematical notation. Spending 3 minutes deciding what your group name is, the Mathinators, and writing that down, didn't count. I then had a bunch of people with me doing the assessment. We would measure how much discussion there was in the group. If there was a lot, they got a 3. If there was none, they got a 0. If there's something in the middle, they got something in the middle. How eager were they to start? How much participation and persistence was there? How much knowledge mobility was there? And how non-linear was their work? Was their work messy? If it was, they got a 3. It turns out that when students are really thinking, their work is messy, for the most part. When they're really just copying something that they already know, it's very neat. The thinking process is messy. And then we averaged it for all the groups of the same type and made a table. So this table are the students who stood up on whiteboards, all those 10 groups. These are ones that had whiteboards at their desk, standing at flip chart paper at their desk, and the control. Someone tell me something you noticed.
Permanent versus non-permanent.
Permanent versus non-permanent? Say what you noticed.
In all categories, the non-permanent seems to be performing better.
Okay. Why is that? Why does the non-permanent work so well? Yes?
Oh, the notebook is actually pretty good.
Yeah, the notebook was good right there. Why is non-permanent so good? Yes?
Because they can make mistakes.
Well, they can make mistakes on paper, too. Oh, it's easy to erase. Yes. This is non-permanent surfaces free them to risk more because they can quickly erase it. The irony is they don't. But because they can, they're quicker to start and they risk more. Anything else you notice? Yeah.
In mobility, actually, the notebook did just as well as the horizontal non-permanent.
So in mobility of knowledge, yes. This was the same as that. And it's because, in fact, the mobility of knowledge sucked when they were sitting down, period. It's really hard for knowledge to move between groups if everyone is sitting. You should have noticed that standing was better. Standing non-permanent is better than sitting non-permanent. And even for the most part, standing permanent is better than sitting permanent. Why is standing good? Because you're on display. Nowhere to hide. Anything else? Yeah?
Everybody can see everything equally as well.
Yeah, everyone can see everything equally. We're still unpacking why this is good. Basically, the conclusion I've come to now is if your bum is numb, your brain is numb. But we're trying to make that sound a little bit more scientific. Anyway, this was so successful, and the people who have been trying it have created a hashtag. I just learned this morning that there's a parallel hashtag, NPVS, which has a lot of people on it. But we stopped calling them whiteboards and started calling them vertical non-permanent surfaces because the vertical mattered and the non-permanent mattered. Those seem to be the central thing. All right, what's it look like? Looks like this.